We have the graph of f, which is a piecewise function. It's defined on the interval from -10 to 7. It's made of 3 linear pieces. Often, when you are given a piecewise graph or something that you need to interpret graphically, they'll tell you what it's comprised of, just in case they're a little tricky and they're like, nope, it was really a curve. Psych. No, it's a straight line. They said so. And it's given above. The function g is defined as, let's read it carefully, g is the integral from -1 to x f of t dt. Well, what's f? Okay, here's f. And g is the integral from -1 to x. So g is an integrally defined function. It's defined as an integral. And it is a function where we are accumulating area, starting at -1 and moving forward, or starting at -1 and moving backwards, depending on what x is. Okay? So let's do the first one. And when I do, we're going to kind of pause after we get here and then talk about these other things because they're a little bit tricky. So the very first thing that's good to know is that g of x is defined as -1 x f of t dt. Got some blank space up here. I'm going to use it in a minute. That is nothing new. They already told me. I'm going to use that to launch into something else in a minute. Let's just hold that space. So g of -1, let's switch to green. I'm just feeling like we should do green on this one, is the integral from -1 to, well, we're going to plug in a -1 for x, which is right here, f of t dt. There we go. There, you'd never know that I messed up on that t. Haha, we'll fix it. dt. Okay, this one's relatively easy. We need to find the accumulated area from -1 to -1, so we don't go anywhere, basically. If I was to say, all right, what's this area right here? 0, right? Because it has 0 width and a height of 4. So 0 times 4 is, well, 0. So those are the easy ones. We can just look at those numbers and realize that. Let's get to the tricky part, though. I need the derivative of g at -1. The derivative of g at -1. Let's see. If I take the derivative of g, then I would be taking the derivative of the left side. We have to take the derivative of the right side as well. And the derivative of an integral just takes me to the function itself. And that is the purpose of this lesson. It is this big idea that integrals and derivatives are inverse operations. And again, here we are back at the fundamental theorem of calculus for derivatives, that if I define a function as an integral, then I take the derivative of both sides and I get the integral, I get the function I was taking the integral of. It's all blending together now. Accumulated area is the integral, and then the derivative of that gives you the original function. It's beautiful. So what I really have here is just f of x. So when they say, what's g prime of -1? What they're really saying is, what is f of -1? Okay, well, f of -1, this is the graph of f. It's 4. So final answer is 4. Okay, don't make it harder than it is. Now I need the second derivative of g. Well, let's come up here and let's do another step. If I take the derivative of this side, we now have the second derivative of g, which gives me the first derivative of f. And therefore, I am asked to talk about the slope at f when I'm asked for the second derivative of g. Okay, so we've kind of gone beyond the realm of accumulating area once we get down here. So what I'm really asked for, again, is the slope of the f function at -1. So I'll look over here and I'll say, what's the slope at that point? Well, this is one of those that is not differentiable at that point. So we have undefined. We have an undefined slope. Okay, let's move on with this idea. G of 3. I am going to plug a 3 into the function. When I plug a 3 into the function, I'm going to have -1 to 3 f of t dt. Okay, -1 to 3. -1 to 3, and I'm going to accumulate this area here. It's this rectangle, and this rectangle is 4 wide, 4 high, so I'm going to write 4 times 4 and put 16. If you just want to be like, it's 16, that's fine too. All right, g prime of 3. Well, we've already established that if I'm taking the derivative of an integral, I get the function I was taking the integral of. And so what I really have here is f of 3. And so we're just going to come over here and say, well, what's f of 3? And it is 4. I don't know why I keep switching colors in between these. I'm just having a wonderful time. You get some pens and you're just going to town with it. It's a lot of fun. Okay, well, g double prime of 3. G double prime of 3 is the first derivative of f. So that tells me I need to find the slope of this function that I'm looking at 3. And I think you can see where this is going. It's similar to the last problem, undefined. Okay, let's kind of speed this process up a little bit. I'm going to go ahead and just write a few things on these that are consistent with what I've seen right here. And I think I can do that with this color like I've been doing on the others. This is really f of 5. This is really g of, whoops, f of 7 is what I meant to say. F of 7. This is really f of negative 5. This is really f of negative 9. And this is really f prime of 5. This is really f prime of 7. This is really f prime of negative 5. And this is really f prime of negative 9. Okay, now that we've established those things, let's start filling in some stuff. These will probably be the easier ones. These are the harder ones because we have to find accumulated area. So let's jump over here. The area from negative 1 to 5, f of t dt is equal to, okay, well, I want to know the area from negative 1 to 5. So now I'm going to take this and then add a little bit more. So what you could do, and I'm going to stretch this out a little bit, not to state the obvious, but to use some properties that are going to come in handy later. The integral from negative 1 to 5 is really the integral from negative 1 to some other place. Well, let's use one we've already found, f of t dt, plus the integral from 3 to 5, f of t dt. We're running out of space. Oops. And let's keep moving. Okay, negative 1 to 3, we already know that one. That area was 16. And we're going to add to it the area from 3 to 5. And we're going to, well, I'm running out of space, but we'll just do a triangle that is 2 by 4. So, oh my goodness, I don't have room. No. 1/2, 2 times 4. So I'm going to have 16 plus 4. So I'm going to have 20 right here. This area that I've shaded from negative 1 to 5 is 20. Okay. F of 5, that's going to be pretty straightforward. That's 0. And the slope at 5, is negative 1. Okay, moving to the next one. G of 7. This one's going to be lovely. You're going to like this. The integral from negative 1 to 7, f of t dt. And I'd love to draw another integral, write another integral and be like, well, it's this area plus this area plus this area. And you could. But it's this area plus this area plus this area. And can we just be really honest with one another? You know what's about to happen, I hope. These two areas are exactly the same. But in the process of figuring this out, this one's positive and this one's negative, and they will cancel each other out, okay? So I'm going to write some stuff that'll lead us to the answer of 16, but it's really 16 plus 4 minus 4. These two have the same area, but they're opposite signs. So 16 plus 4 minus 4 equals 16. There we go. F of 7, let's see, f of 7 is negative 4. And this is a tricky one, all right? We're tempted to say f prime of 7. Oh, that's on this line that has a slope of negative 2. And no, actually. I mean, yes, it's on that line, but we cannot talk about the slope at a point without talking about the slope coming from both sides, okay? There is an alternate form of a derivative that I'm not going to take the time to write right now. I'm almost reached for some blank paper and wrote it, but I'm not. But there's an alternate form of a derivative, and it has to do basically with this. If I want to find the slope at any given point, like negative 5 or positive 5, I'd say, oh, the slope from this side is this, the slope from this side is that, and it was negative, whoa, that's negative 2, not negative 1. I am very sorry. I'm not going to start this video over just for that. My bad. That is a negative 2. I'm glad I went back and talked about it. Okay, the slope is negative 2. The slope is negative 2. At 7, the slope is negative 2. The slope is... Wait, where's my graph? Okay, so this one's undefined. Undefined. All right. Now things get fun. And just when you thought you were having a lot of fun, it gets funner. The slope, not the slope, the area from -1 to -5 of f of t dt. And I'm just going to go ahead and jump in with a thought that I have very frequently about these. These numbers are backwards. If they're backwards, I like to have a habit of turning them around and putting the smaller one first. It is not a requirement, but it's just a good little strategy. So negative, and then -5 to -1. Okay, well now I'm going to find the area from -5 to -1, which would be 1/2 4 times 4. But I just sort of lied, so it's -1/2 4 times 4, and that's going to give me -8. Okay, let's find f of -5. F of -5 is 0. Here, let's do a little zoomy zoom here. Okay, f prime of -5, that would be the slope of this line. The slope of this line is consistently +1 because it's a line, has a constant slope. There we go. And that one's right. That one's fixed, but that one's right also. Okay, let me kind of pause and talk about this one for a second. You know how we turned this one around and we changed the sign in front and we're like, yeah, we can do it that way, and it's great. You could also do it a different way. You could still compute the area from -1 to -5, and in the process of doing so, when you talk about the length, notice the air quotes, the length of the base, you would be computing it backwards. So we would say it is 1/2, area of a triangle, 1/2 -4 times +4. So we would have to go back, and therefore the negative would kind of be here, and we'd still get -8. All right, let's keep going. This next one is kind of fun. The integral from -1 to -9 f of t dt. And that's going to be the area from, check it out, -1 to -9. Here's an area, here's an area. They're the same, but one of them is positive, the other one's negative. Actually, let me rephrase that. One of them is, watch where I'm pointing, positive, the other one's negative. Whoa, you're pointing at the wrong ones. I know. I'm not, but I am, but I'm not. If we were to move backwards, then technically, I just said this, but I would count this as -4 times +4. So this one would be negative if I'm moving backwards. And then this one would be positive because it's -4 times -4. And then, of course, half because it's a triangle. So I'd have a negative times a negative. This one would be positive. Interesting. So what really happened was I would have 0. They cancel each other out. That's not the actual area like, hey, what's my square footage? But it is the computed area as we move from -1 to -9, or even if we move from -9 to -1. Okay, f of -9, that's just the value of the function, and that would be -4. And f prime of -9 is the slope of the line. So that one would be 1.